Good morning, this is your Stat Sensei, Mr. Spensei, and this is a one sample t-test. The scenario is highly caffeinated, and we went over this in the warm-up. So we're actually going to run the full hypothesis test, specifically at the zero point zero 0.01 significance level. So they're telling us right now, based on that zero point zero 0.01, that alpha equals zero point zero 0.01. I'm going to go ahead and highlight that so we know where we got that information from. All right. So there are more than 10 million young adults, that's my population size, that consume caffeinated beverages in the US. A coffee company asserts, in other words, that's another word for claims, that the average US adults consume an average of 180 milligrams per day. So that's my claim. That sounds like a null hypothesis. A nutrition believes that young adults consume more. That's probably going to be important because that's probably going to be my alternative of mu of greater than 180 milligrams of caffeine and collects data from a random sample. Yay. There's my first condition of 95, and 95 will be my sample size, finding that the average caffeine intake is 190.3, so X bar is 190.3 with a standard deviation of 45 milligrams. And there's the sample standard deviation. And remember, if the standard deviation comes from the sample, we have to run a t-test. If it's a population standard deviation, we can run a z. All right, so they want us to run a t-test. So this is t equals x bar minus mu s divided by the square root of n. We've also been running a paired. Paired had the d's on it. There's no before and after, so there should be no d's. So I don't want to see d's. If you have d's, it's going to be wrong. All right, so what's our important information? Well, we know the mean is 180 because they told us 180 milligrams. They told us the sample mean was 190.3, so there's 190.3 milligrams. And our sample standard deviation, they said, was, where did it go? 45 milligrams, and here it is right here. And then we know our sample size is 95. We are running a one sample t-test. Do not use the word paired. This was not paired. This is not a before and after, so just one sample t-test. Well, it's a hypothesis test. All hypothesis tests are centered on the population mean or on the claim. So it'll be centered on this. Confidence intervals are centered on X bars. Hypothesis tests are centered on the population mean. So we're going to be centered on the population mean. And they said uh, that, where was the key word? Keyword is more. So the more tells me this is a greater than. All right. More is the key word that tells me this is a greater than. So I can go ahead and plug in. And when I plug in, it's 190.3 in for my X bar, 180 for my mu, 45 is my sample standard deviation, and 90 square root of 95. So once again, X bar, mu, S, and N. The hypothesis. Well, the hypothesis will be that it equals 180. Remember, the null hypothesis is always equal. So this equals 180 milligrams. The alternative is that it's greater than 180 milligrams because of the word more that they used earlier and that we have marked up here. So our parameter, let mu equal the true population mean amount of caffeine consumed daily. Paired, mean amount of the differences, not paired, so just mean. All right, so make sure that you only use the word mean here. All right, when we look back at the scenario, they told us it was a random sample. All right, so random sample of 95, and that was given to us. So we can go ahead and random sample of 95 given, put a check mark. Well, 95 times 10, we're always multiplying by 10. 95 times 10 is 950. And they told us our population was 10 million. So N is less than 10% of the population. All right. So basically, this is saying, hey, we need our sample can't be too big. The next thing is our sample has to be big enough. And 95 is greater than 30. So normal by central limit theorem. Please remember we're always comparing to 30. So we've checked off our normality condition. All three conditions have been met. At this point, we can go ahead and run our test. So to do that, I need to go back and put this information in the calculator. So stat test, just a one sample t-test. Stats needs to be highlighted. Our mean is 180. Our sample mean is 190.3. Our sample standard deviation is 45 and our sample size is 95. And we said greater than or more, so I need to make sure that I have that highlighted. So there's greater than. And I calculate, and I get a t-statistic of 2.2309 and a p-value of 0.143. So the probability that t is greater than 2.3109, by the way, this value, this greater than sign, that came from my alternative hypothesis, which is also the same as what I marked up here. So those things always need to be the same, is 0.01403. Okay, they told us our alpha level is 0.01. Well, 0.0140 is greater than 0.01. Remember, make them the same length. So 140 is bigger than 100. So because it's bigger, we're going to fail to reject. So our conclusion, our p-value is 0.0140, which is greater than our alpha 0.01. Please remember, this first part comes from right here. Our p-value is 0.0410, which is greater than our alpha 0.01. We fail to reject the null. When we fail to reject, there is not enough. There's not sufficient evidence to suggest the true population mean amount of caffeine consumed daily is more than 180 milligrams. Now, the true population mean amount of caffeine consumed daily, that's just a restatement of our parameter. The true population mean amount of caffeine consumed daily is more than 180. Well, where did that is more than 180 come from? That is more than 180. That's our alternative hypothesis, which says greater than 180. So more than 180. So please remember this part right here is our alternative hypothesis. All right, this concludes this video. Appreciate you watching. I hope to see you on the next one. Thank you.